For this bell ringer, they want us to figure out the radius, the diameter, and the circumference given the area of the circle. So the key to figuring this out is remembering, hey, well, I know what the formula for area is, right? Area is pi r squared. And there's lots of ways that you can think through this. You could just look at the problem and ask yourself, all right, well, what value of r makes 16 pi, right? You can do that, and that totally works, especially in one like this where they give you a nice, good number. But if that's not something that you see immediately, and that's fine, all you have to do is say, all right, well, the area is 16 pi. Let's put that here. And then we can divide both sides by pi. And then 16 is going to be r squared, so square root both sides. You get r equals 4. So there's the radius. Well, that's the radius. What's the diameter? How do we go from radius to diameter? What do we do? Times 2. That's exactly right. Pretty cool. So yeah, we're just going to take the radius and times 2 and get the diameter. Is going to be 8. And then circumference. Well, how do I do that? Well, just remember the formula. You can do pi d or 2 pi r. It'll give you the same thing in the end, right? But either way it goes, I want to find the circumference. 2 radius times pi, or if you prefer diameter times pi, gives you circumference right here. All right, so here's what we're talking about. We're going to be finding the surface area and volume of a sphere. Let's start with surface area. And so the formula is surface area 4 pi r squared. And basically, what we should be imagining, and this will kind of help motivate you to remember this, it's like if you've ever seen a baseball, right? You know how the outer layer of the baseball is all stitched together. Have anyone ever torn apart a baseball? Is it just me? So if you were to like cut the stitches and take off the outer layer, it's like 2 pieces like this. If you were to, stretch them out, kind of like they do here, it's basically 4 circles. And 4 pi r squared is 4 circles, right? So if you think about it in that way, surface area is not going to be that hard to deal with. It's just find the area of a circle and then times 4. All right? We've got lots of stuff and pictures here. The vocabulary is probably important to talk about real quick. So first things first, a sphere is really interesting because anywhere you slice along that sphere, if you just cut and then you look at the cut piece, you get a circle. So yeah, so if you look at a sphere, if you were to cut it, what would happen is you would automatically basically get a circle out of the part that you cut. Like imagine an orange or something like that. If you slice an orange, it doesn't matter where you slice it. You take the slice, the piece that you cut is a circle, and then the imprint from where you left, where the knife was, also a circle. Always. Now, the biggest circle that you can make is when you cut the sphere right down the middle. All right, so you've got what's called a great circle. That's when you cut through the middle of the sphere directly, like the equator of the Earth, right? That is a great circle. Not like quality, but great, like isn't big, right? I'm sure it's great too, but you know. And then the two pieces, if you make a great circle, if you cut it right down the middle like that, the two pieces are referred to as hemispheres. Those of you who have taken geography, I'm sure you've talked about the northern hemisphere, the southern hemisphere, etc. Hemisphere, hemi, half, sphere, right? Yeah, so there's some vocabulary. So let's practice this now. We're gonna find the surface area of a couple spheres. Now, remember the surface area is 4 pi r squared. But is this r? Is this a radius? No, it's a diameter, right? So since it's a diameter, we have to do what to it? Divide by 2. So the diameter is 10, but we don't want the diameter, right? We want the radius, which is 5. And all we're going to do is we're just going to throw it in there. 4 pi times 5 squared. Well, 5 squared is 25, times 4 is 100. So we end up with that many. Or what are our units? Meters squared. Remember, surface area, meters squared. If we're talking about volume, it would be meters cubed, right? So go ahead, give this one a try. Surface area of a sphere, and we want the diameter is 14 inches. They're saying give your answer in terms of pi, and then also round it to the nearest square inch. So basically what they're asking for, we did this a couple times last week, but just as a reminder, first answer it in terms of pi like we did the previous problem, and then take that answer, throw it into the calculator, and write out the decimal approximation of the answer that you came up with. All right, so once again, what's the surface area? Well, it's 4 pi r squared. And we want to deal with this. They tell us the diameter is 14 inches, but we don't want the diameter. We want the radius. The radius is 7, right? So we plug in 7. Well, 7 squared is 49 times 4 is 196. Don't forget your pi. And what are my units? Inches squared. And then they also wanted us to take that number and rewrite it as a decimal, rounded to the nearest square inch. So when we do that, what do we get? Let's find out together. Too lazy to walk over and get a calculator. I'm going to use my 196. Where's pi on this thing? There it is, pi. And so we round and we get so there's the answer that the calculator pumps out. And we want to round to the nearest square inch, right? So we look at this next number. That's a 7. So this rounds up, and so our answer is going to be 616 inches squared. All right? Nearest square inch. Okay. So what next? Earth's equator is about 24,902 miles long. What's the approximate surface area of the Earth? Well, if you think about it, when they're talking about the equator, they're talking about circumference, right? Well, what's circumference? It's like that, right? That'll allow us to find R, which will allow us to find the approximate surface area of the Earth. All right, let's do this thing. We've got 2 pi r equals 24,902. So we're going to divide by 2 pi. Let's divide by 2 and then divide by pi. I take this and I divide it by 2, I get that, right? And then I'm going to divide by pi. Now, don't bother putting this in the calculator yet. Otherwise, you're going to have to carry around this ugly, dumb decimal for a while. Just leave it like this. If you leave it like this, that's a lot less to write down, right? So, from here, we've got our radius. Let's go ahead and figure out our surface area. Let's move you over to the side. This way. There we go. So now, let's find the surface area. And now, if you put that into the calculator, you're going to get the exact answer. The book is even going to try and say, hey, listen, round it right now, and then put it in there. And you can do that. I'm not going to tell you that that's going to give you a wrong answer, especially when they're having you round to the nearest kilometer. You're going to be fine, right? But, or not kilometer, my bad. Nearest 1,000 miles, not 1,000 meters, 1,000 miles. But so I'm not saying like one way is better than the other. So whichever way you prefer is up to you. Like if you want to do 12,451 over pi and get like 4,000 something for your radius, and then plug 4,000 in, get, you know, whatever, 16,000 something times 4, so 64,000 pi something. Sure, do that. That'll be just fine. But watch out for rounding. If you use the decimal that you make here, you got to use that decimal for the whole rest of the problem, right? And so, me personally, Mr. Webster, I ain't want to do that. I don't have to write out a big long decimal in every single step. Put a big long decimal up in here. That's a pain in the butt for me. That's how I feel. If you want to do it that way, you do it that way. But like, I would rather leave it like this. I would rather put it into the calculator like this. But if you don't want to do that, that confuses you. That causes problems. Maybe you're like, you have trouble putting it into the calculator looking like this. Then the decimal approximation is still fine, right? But just a warning, if you are putting this into the calculator, 4 times pi times parentheses 12,451 divided by pi close parentheses squared. That's how it would go into the calculator, just so you're comfortable with that. So now we're going to calculate it out. 4 times pi times parentheses 12,451 over pi close parentheses squared. And we get the following number. And it keeps on going, right? But this is what my calculator is able to give me. They say nearest 1,000 square miles. So we're looking at the 1,000 place, and that's a 0, so we're going to round it down, right? So we're going to round it down to 197,387,000 square miles. All right. So to feel a lot better about a problem like this, consider it in two separate steps, okay? When they ask you, just like in the bell ringer, you notice I gave you all those steps built into the problem, right? They're like little checkpoints. I have the circumference, I want the surface area. So you're going to go circumference, find the radius, find the surface area. And that's going to save you a lot of sort of mental anguish. You know what I mean? Because you won't be thinking as hard about it as like one whole big old problem, and you'll think about it as two tiny problems. Because how easy is it to just find the radius? Easy. If I have the radius, how easy is it to find the surface area? Easy. But I feel like somehow when we try and combine this into one complete problem, just one problem on its own, from A to Z, it feels like a nightmare. Because it's like you're doing so much, right? So my recommendation to you when you're doing this is think about it like two problems. I've got the circumference. Well, I don't want the circumference. I want the radius. I'll find the radius. Now that I got the radius, new problem. Find the surface area. All right? So I want you to try this now. We're going to find the surface. Now it's not the whole Earth. It's a melon. It's got a circumference of 18 inches. And we want to know the surface area of the melon. Okay. So they tell us the circumference is 18. Well, we don't want the circumference. We want the radius. So here's the circumference. And we're going to solve for r. So we're going to divide by 2, divide by pi, right? I divide by 2, I get 9. Divide by pi, I get 9 over pi. And just leave it like that. Because you can just put it into the surface area just like that. 4 pi squared, like that. Right? And then you don't have to do any more than that. Just put it into the calculator, right? Four pi times parentheses 9 over pi squared. And look what you get. You get 103.1324031. They say nearest 10 square inches. So we want to figure out, are we rounding that up or down? The 3 rounds down, so we get 100 inches squared. And that's all there is to that. Pretty simple, right? Not hard. Especially if you take the time to break it down into two separate steps. Find the radius, then go forward and find the surface area. Let it be that easy. Let it be that easy, because so many times people are sitting here like trying to overthink this. Well, how do I do? Don't worry about going straight from one to the other. Ain't nobody got time for that. Take a pit stop in the middle. Find the radius first. That way you know where you're going, you know where you've been. So now, time for volume. The only thing that makes the volume one a little bit more complicated looking is that there's a fraction in there. 4/3 pi r cubed. We were taking calculus, we talk about how you take the derivative of volume, you get the surface area. But we're not in calculus. We won't talk about that. But same exact problem. Now, instead of it being 4 pi r squared, it's just 4/3 pi r cubed. The only thing that changes is that the 4 now has a 3 over it, or a 3 under it, and the exponent on the radius is 3 instead of 2, right? Literally all that happened. All right, so we're going to do the exact same thing we've been doing. Hey, what's the radius? Okay, plug it in, find our answer. The one thing I'll tell you that's going to potentially make it won't happen in this one. This one's going to make it very easy. But if your radius is not a multiple of 3, you're going to have a decimal answer, which is fine. But what you might want to do is just leave it as a fraction in simplest form, unless you're told otherwise. And I'll show you with one of these, hopefully. But I'll show you what I'm talking about. But still, the volume here, 4/3 pi r cubed. Well, we get r. R is 6. Six cubed is 216. 36 times 6, 36, 80, 216. Yes. Okay. So we got, let's take a look here. We got like this, right? What you might want to do, it's going to work out in this case because 216 is a multiple of 3, because 6 was a multiple of 3, right? What you might want to do, if you're in a situation where this is not a good number, let's say it's, I don't know, 8. You take 8 and divide it by 3, you're going to get a decimal, right? So my recommendation would be just take this number, multiply it to the 4, and then have that before you bother trying to divide by 3. Because if you divide by 3 and it don't work, you can be like, oh, I can just go back a step and leave it as a fraction. You know what I mean? So like, here's the way I would work some of these situations where it comes out weird. I'm going to say, all right, well, let me just do 216 times 4 real quick. So this is potentially your answer. The only thing that could happen here is I could simplify the 3, right? So let me really quick do 864 divided by 3, and it comes out nicely. So I can take one more step and write that. But like, if you're using a calculator anyway, right? If you get this, and then you get like 200.33333 or whatever, that ain't gonna fly, right? They're not gonna want that. They're gonna want it as a good answer. So my recommendation is to do this one extra step because it could save you a little bit of heartache in the long run. Here, the only thing that you might have to do is simplify it if it simplifies. That's if. That's a big if. Because if the radius is not a multiple of 3, let's say that the radius was 8, you'd end up with something a lot uglier. All right? So once again, for the most part, just, what's the radius? Cube it times 4, write it out, just so you have it. then divide by 3. If it comes out nice, booyah. You can make it simpler. If it doesn't come out nice, leave it here. You know? Okay. Give this one a try. So the diameter here is 60 inches, and we want to know the volume. This is also going to come out nice, which is great. Diameter is 60, but we don't want the diameter, we want the radius. Find the radius. 30, right? Volume is 4/3 pi r cubed. Now they want the volume to the nearest cubic inch, so once you plug that in, you can just sort of let the calculator do all the rest and just move on with your life. If they were asking for it in terms of pi, break it down, take a couple extra steps just so that you make it easy on yourself. But like, just doing it that way, because they want volume to the nearest cubic inch. You're going to put pi and everything in there. So you can just go ahead and do 4 divided by 3 times pi times 30 raised to the 3rd power. You're going to get, they want it rounded to the nearest cubic inch. So nearest cubic inch, that 3 doesn't round up. So we're left with 11,000. Thank you. 113,097 inches cubed. All right. You feeling okay about that? All right. The only other thing that I can do at this point is more of like what we did. Here's the volume, but we want the surface area. So once again, don't try and turn this into one humongous big problem. Take a second, do it one bit at a time. Find the radius first. The volume of a sphere is 5,000. So we're going to times 3 divide by 4. So we do that. Then we're going to divide by pi and cube root. So cube root with this one. And once again, do I have to break that down into a decimal? I could, right? You totally could take that, break it down to a decimal, and then have to carry that decimal for the rest of the time. Yeah.
What did you just do to get 3,750?
So first I multiplied by 3 and divided by 4 to get rid of that, right? Because I'm trying to solve for r, right? I'm just taking it apart one piece at a time.
Okay.
To say it another way, I multiplied by the reciprocal of the fraction, right? Times 3/4. That make sense?
Mm-hmm.
Everybody cool with that? Thank you for asking that question. I appreciate it.
Mm-hmm.
All right, so I found r. It's this ugly mess right here. And you know, you may feel like, hey, I'd rather deal with a decimal than have to do that all the time. Is that fine? Yes, it is. If you'd rather leave it like this, to me, I'm thinking about, you know, the space I want to have to write on the paper. That's a lot less writing than a whole big long string of numbers. But if you would rather make that as a decimal, we note that we're going to be rounding to the nearest meter. So as long as we keep what's in the window of the calculator, we should be okay the whole time, okay? No, you stay here. the other one. There's part 1. Now for part 2. I found the radius. Now let's find the surface area. Four pi r squared, right? So let's take that and square it. So that can just go into the calculator and then you're done. Now, notice that's a cube root, not a square root, right? There's a separate button for cube roots on this calculator here. On the TI calculators that we have in the classroom, if you hit second caret, you know, the little caret button, one that looks like this, the raised to the power button, that'll get you a cube root. And here's how you do it. It's doing cube roots on here. On this one is a little harder because it doesn't have like the little Matthew thing where you can like plug in the numbers where they're supposed to go. If you're using this, the way you're going to type it in, 4 pi times 3, and then the little thing here, button, times this whole thing squared. That will get you the right answer on this. 4 pi times parentheses the cube root of 37.2 close parentheses, oops, over pi, close parentheses, square. But so for one like this, in terms of how easy it is to put into the calculator, maybe for this one you use a decimal. You know, like there's no correct one way to go, right? It's okay for you to say, you know what, in this situation I'd rather do it this way, in this situation I'd rather do it that way, because, you know, economy of work, right? I don't know about you, but I'd rather be as lazy as humanly possible when I'm trying to do my work, right? I don't want to have to sit there and work harder than I have to for no reason. Yeah, there's being industrious, there's being studious, and then there's understanding that there's an economy of motion, right? I don't know if this story is apocryphal or not. I hear this story all the time. It's probably not true, but there's a story that goes around about how, you know, Bill Gates was speaking to a school and they were trying to underline the importance of hard work. And Bill Gates was like, well, when it comes to it, I'd rather have someone who's lazy because they know how to find the answer the quickest and the easiest, right? Same idea. Now, obviously, in order to be able to find the answer the quickest and the easiest, you have to understand well how the work goes. So hard work is different than working hard sometimes, you know? Sometimes working good and working hard are not the same. So that's enough about that. Let me, meters squared. Oh, rounded to the nearest square meter. Oh, So 307, right? Yeah, we feeling okay about this? Now, again, am I gonna force you to do it one particular way? Especially if it's all being dumped into the calculator, you know that you're gonna be able to sort of go your own way. And as long as you get the same answer that I do, you know you're fine, right? Okay, this is the last thing. So find the surface area if the volume is 4,200 feet cubed. And this is, by the way, absolutely the most common mistake. The fact that you made it underlines that. Everybody makes this mistake. I want to get rid of this 4/3, right? Well, if I move it to the other side, everything has to switch. So I'm going to multiply both sides by 3/4, just to, wait, that cancels out with that, that cancels out with that. 4,200 times 3 divided by 4, what did I write down? Should be 3,150, right? All right, everybody with me there? So then, just like normal, divide by pi and cube root, get your r. No, go up here. So now, it's just a matter of putting that into the calculator for surface area, right? So that squared times 4 pi had better get you this number I have right here. 1,258.878022. And then again, it says round to the nearest tenth. So I'm going to round to the nearest tenth. Here's my tenths. Here's my hundredths. That 7 is the hundredths place. The 5 are bigger, so I round up. My units are feet squared, since I'm finding surface area.